Hey everyone, my name's Lauren, and today we're going to be talking about scientific notation, chemistry edition. I know you probably can't see this at all right now. I promise you will be able to see it a little bit later. I tried using my camera to film today, so I had to work around with the setup a little bit and whatnot. So why should you use scientific notation? Well, first of all, it makes it easier to represent really big or really small numbers. And also, it's commonly what's used in science and math numeric expressions. So again, we're talking about math. Chemistry is a lot of math, so that is going to be the focus again today. And it's just a quick way to have a nice, easy representation of really outrageous numbers, if numbers can even be outrageous. I think they can. So again, you'll be able to see this better in a few seconds. Like now, sort of, ish. Still having issues. Alrighty, so you can expect two different types of math. The first type is going to be multiplication. Shouldn't be too hard. And your second one's going to be exponents. And we're only talking about powers of 10 here. So overall, scientific notation is about expressing these really big numbers or really small numbers by using powers of 10, so your exponents, as a quick and easy tool to help you out. Alrighty, moving on to the format of scientific notation. We're going to work through an example together. So let's say that we have a pretty big number. How about 30,000? I can read numbers. Alrighty, so step number 1. I like to call this the strip step because essentially you're going to strip the numbers that aren't 0 off of the larger number. So we got the 3 in our zeros there. That's kind of what I think of whenever I say strip the numbers off, but you can think of it however you want. Step number 2, we're going to count the number of zeros that we have left. And you can probably see here that we have 4 zeros. And moving right along to step 3, we're just going to write it out and I'll show you the basic format there. So we have 3 times 10 to the 4th. And the 3 is the non-zero number that we stripped off. The exponent 4 there is the number of zeros that we counted. And remember that we're always talking about powers of 10s whenever we're talking about scientific notation. If you don't have a 10, then you're probably doing something wrong. And always remember to multiply. There's always a multiplication sign in between your number and your 10 to the whatever power. Alrighty, so a quick note to make, which is actually pretty important when you're working with scientific notation, is that if you have a large number, the exponent on the 10 will be a positive number. That signifies that you do have a large number because the power of 10 is getting greater and greater when you increase the exponent. And vice versa, if you have a small number, the exponent will be a negative number, which shows that you're getting smaller and smaller past 0. This is pretty important because if you accidentally put the wrong sign, then you can totally mean a different number when you're working with your scientific notation. And I had some problems with my highlighter here, so don't mind that. And you'll see this again as I try to cover everything up so you can read it better in blue. Still didn't work too well, but we'll go with it. Alrighty, so we're going to try an example. So try this on your own first. So pause the video because this does go a little quick, and make sure that you can do it on your own before I work it out with you and for you. So your problem is, how would you express the number 410,000 in scientific notation? So again, take a second, do it on your own. So we should have gotten 4.1 times 10 to the 5th. And you may be wondering, but why is the 10 raised to the 5th instead of the 4th? Because there's 4 zeros, right? Like, I thought that's what you told us earlier. Well, since we have 2 non-zero numbers, we're going to have to add an extra quote-unquote 0, or essentially raise the power by 1. And by doing that, we are accounting for the decimal place between the 4 and the 1. And this works with any number that has 2 or more non-zero numbers. So this is just a quick note to make. You always have to account for the decimal place by adding another exponent. Okay, so now we're going to go in reverse and work with a smaller number than 0. So again, pause the video, try this problem here on your own before moving on and seeing what I am going to show you. So your problem is, how would you express the number 0.007 in scientific notation? So again, take your time, see if you can do it before I work it out for you. We get to listen to the fun music brought to you by royalty-free iMovie. Alright, so you should have gotten 7 times 10 to the negative 3. We'll go over this. So your 7 is your non-zero number, just like before with the larger numbers. The 3 there on the exponent is how many zeros you have. And don't forget your negative, because this is a small number and not a large number. So if you forgot the negative, then you would essentially be saying that this is a larger number. And since we're talking about this in a chemistry perspective, we'll always be working with different units. So like any math and chemistry, don't forget your units, or else you will get points taken off depending on your teacher. I know teachers most likely will take off points. Very important, do not forget your units. And you can see me struggle here with my camera, with my zoom, but I'm basically emphasizing don't forget your units. Just don't. It's bad. Alrighty, and we can disregard this statement because I made a mistake and accidentally tried to end the video early before I showed you how the calculator plays a role in scientific notation. So this is your break while I think that I'm done with the video, even though I'm not. We'll get to that a little bit later, not too much longer. You're almost through. And here is me realizing that I messed up and forgot the calculator section. Anyways, I'm going to be using a TI-84 plus CE. It's my school calculator that I use pretty much every day. And I'm pretty much going to use the second button to type an E. That E is also the comma button. So the E stands for the times 10 in scientific notation. So you don't need to write times 10 and then little caret with the exponent. You can just simply type the second button, which will give you the shift function, and use the comma button for that double EE. It should be written in blue above the comma button. It's not too difficult to find. You just have to, you get better at it as you keep using it. And you can see negative numbers make smaller numbers, and bigger numbers have a positive exponent. And now we're actually done. So thanks for watching.